my name is Tim, and I'm the robotics application specialist. One of the big projects that we worked on this year was for our existing Mindstorms users that wanted to use the TETRIX products within the EV3 software. So this was a big goal, the project for us, to get programming blocks that they could actually use and work with the TETRIX hardware with the EV3 controller, all native within the EV3 software. So we're glad to be able to announce we actually posted, they've been up about a month, but we're glad that we've actually got that project done. And we wanted to take a minute through this webinar venue and kind of hopefully walk people through some of the process on how they actually work, some of the tips and tricks on how they work with the hardware, so that the whole process becomes a little bit easier. So what I want to start with is basically making sure everybody understands that they can go to www.tetrixrobotics.com, and if they there's a banner that will flash across one of four, that if they click on that link, it will take them to a download page where they can download not only the EV3 programming blocks, but also a project that we did within the EV3 software. And we're going to go through that project step by step today, so that you've got a little bit of a foundation and a working start with the programming blocks. And then also I just want to make sure that there are instructions there for you to be able to, if you're not comfortable with the importing of the blocks, there's instructions there for that as well. So anyway, we just want to kind of go through some of those things, make sure everybody's comfortable with that, and give you guys a chance to ask questions. And I want to talk a little bit about the different features of the blocks. We have a mode button that gives you, when you click on the move motors, this is the DC motors, and this is, hopefully we tried to model this just like off of the regular EV3 blocks, like the regular Lego blocks, so it would be very comfortable for you and how you react with this. But it's got 3 mode options. We can measure and we can read the encoders if you have encoders. So that's very important to know that the DC motors don't come with native encoders on the motors. So that would be something that you have to add to the motors to be able to use this function in the block. But we wanted to put it in the block. So if you've got encoders on your motors, you can read those, or you can read the voltage from the motors. Notice that when I choose a particular mode on the block, my options to the right actually change. So if I'm on measure, read encoders, I can choose, the first option is I can choose which of the high-technic controllers. If I have multiple controllers on my robot, I can choose which controller I want to read, like 1, 2, 3, or 4 in a daisy chain, because to remember, we can daisy chain these blocks up. I can choose the controller, and then I can choose which each controller will control 2 motors. So I can choose 1 or 2 of the encoders, and I can wire that to another block if I want to read that information and display it or somehow use that. So again, that's the measure option, and then when I do voltage, I have the same thing. I can choose the controller. I can choose to read that voltage off of that controller. The next one is probably the one that most people are going to use the most, and that's the move function, or the move mode. It's kind of hard to say fast.
Move mode.
Yeah. So when we say move, we can actually move unlimited. This is similar to the Lego motors, where you just tell the motor to turn on. Once you set that to unlimited, again, you have an option for a controller box. So if you're going to move multiple motors at the same time with multiple controllers, you're going to have to set multiple move blocks. But I can choose which controller. I can tell it that I want to talk to motor number 1. I can tell it motor number 2, or I can tell both motors. I can talk to both motors at the same time. Notice that when if I choose one motor, then I get a power level for that motor. But because I'm only talking to one, this power mode is not available. If I change that to both motors at the same time,
then I can give both motors a valid power level. Or if I go back and choose number 2, you'll see that number 1 now is invalid. So those are the 2 power levels. And then the other option is that I can invert one of the motors. I can tell if I'm talking to 2 motors and I've got them mounted on my robot in opposition. That means they're kind of back to back or front to front. So they in order to work together, they have to go in opposite directions. I can actually choose to invert one of those so that I can leave both values here in a positive or negative value, and it's going to make more sense visually. I don't have to do that, but I can. It's an option that's there. And again, I hope everyone, if you have questions, please don't be afraid to bring those up so we can address any of the issues that you have or questions that you have. The next option in the move category is obviously if you don't move, then you might want to stop. That's pretty self-explanatory. Again, we can choose controller in the chain that we want. We can choose 1, 2, or both of the motors, and then we can choose what kind of a stop we want it to be. It can be a hard stop or a brake, or it can be a float where we let the motors coast down. So that's, again, pretty self-explanatory, almost exactly like the Lego motors. We next have an option for a constant speed. This is basically a PID function where we can, again, talk to the motors and we can try and tell it, I want you to try and maintain a certain speed. For instance, if my robot begins to go uphill, or if I've got all of a sudden an increased load that somehow impacts the robot, I can, by measuring encoder values, I can try and maintain an RPM so that as it's going up speed, it might increase power to the motors and actually try and maintain whatever RPM it started at. Again, please be aware this is dependent on having encoder options on your motor. So if you don't have encoders, this is a feature that will not work for you. It'll turn your motors on, but it won't actually engage the PID function. After constant speed, we can tell it again to move degrees, just like you could a Lego motor if you've got, again, an encoder. So you'll see that a lot of the functionality of these blocks, that if you don't have encoders, you're going to miss out a little bit of what are the available features that you can use with the programming block. Again, I can choose a power level, and in addition to a power level, I can tell it how many degrees I want to move. And again, remember that the like a full rotation is 360 degrees. So if I put in a value of 720, obviously I'm asking it to turn 2 full rotations. That's axle rotations. If you've got a gearing involved or an indirect drive, that might not relate to actual wheel rotations, but it is axle rotations. Once you've accomplished or reached your target of degrees, you can choose again the next action, whether it would be a stop, float, and then finally you can again decide to invert one or both of those motors if you need to. So that's degrees. Rotations, it's going to be very much the same. The only difference in that value is instead of degrees, you're going to actually tell it to go full rotations or 1.5 rotations, something along those lines. Again, that's kind of a difference between resolution. If you're talking 1 full revolutions or 300, break that up into 360 degrees. Again, you can see where the degree option is going to give you a little better resolution in your movement. The next operation, or the last one, is encoder position. This is going to be take advantage of the full optical encoder of that we have for the TETRIX motor. It's the optical encoder actually will break those degrees down into quarter segments. So we can actually, for a full 360 degrees, our optical encoder will actually read 100 or 1,440 4 times 360 counts. So you can see if you really want to get very accurate, this is basically the same as reading the raw data coming from the optical encoder. It is considered a high resolution optical encoder. So you can see that with that you get to, you've got options to, or availability to a high degree of accuracy with reading the encoder position. And last but not least, with the mode button, we have 2 different operations. We can reset the encoder if you need to at any point in time, if you're navigating via dead reckoning. If you want to reset that, you can. And then this last one is probably very important. It's called set timeout. And basically what this one does is there is in the high technique control boxes, there's by default a safety measure that if the block doesn't hear from a controller or programmer, the programmable brain, about every 3 seconds, about 2.5 to 3 seconds, it thinks there's a problem. So to keep from having runaway robots or a safety issue, there by default is a timeout invoked. And if you don't want to use that timeout, then you have to actually disable it with this operation under, excuse me, set timeout. And when you set timeout, you have again an option to talk to whichever controller that you want, and it's going to affect both motors on that particular controller. And you can either say true or false as far as yes, I want it to use the encoder or the timeout, or no, you do not. And we'll cover this a little bit more actually as I go through the project files, so you'll see how that exactly works. So that's the move motor block. I'm going to drag it off, and I'm going to bring out the servo block. Again, we have a mode button that when we look at that, we can read the servo position. We have the same 4 controllers because, again, we can daisy chain multiple controllers on one EV3 port. So, for instance, if my motor controller is the first one in the chain, my servo controller might be number 2. So we want to make sure that you address whichever controller box it is in that particular chain. And then once you have the box chosen, then you actually have, again, 6 different servos that can be on each box. And for this one, that when we're just reading the servo position, then we would wire that value out and take it to another block so that you could actually use that information. Once we have the read position, we also then can basically tell it to move. The servo block actually is a little bit simpler to use in some ways because it's got less features, but again, you can choose your controller box, you can tell which servo that you want it to move, and then you can give it a position. And that position for this block actually goes from 0 to 255. That's a standard servo range that does not correspond necessarily to degrees. So you have to make sure that you remember that if I put in 30 for my position, that doesn't correspond necessarily to 30 degrees. You get a little bit finer control with the encoder count or the position count than you do with degrees. But halfway would be 128. So if you think of that, and again, you can type in that value if you wanted to, if you have trouble using the slider bar. But that's going to be the default mid position. That's where most servos will initialize to that mid position or try to go to that. So that would be the move, and then the last one would be update interval. And basically this allows you to try and sync the servos so that they move to position either as fast as they can or at another speed if you want that. Again, and 0 being as fast as it can, and then 15 being the slowest amount. So you can try, again, if you need to slow one servo down versus another, you can try and play with the speed a little bit and make sure that they arrive to the same position at the same time. So that's the servo block. So I hope everyone kind of gets the basic idea of the two blocks. If we don't have any questions, we're going to go ahead and jump into the project file. What do you think, Ruthie? Are we ready to go on into the project?
I think so. Does anyone have any questions? We'll kind of open it up right now for some questions before we jump in.
I've been talking and coughing and everybody's here. I apologize for that.
All right, I think we're good.
Okay, I'm going to go ahead and just close this window out because we know it's just a blank project. I do not want to save. So again, this is my, the project's title is Getting Started, TETRIX and EV3. When I first open my window up, you are going to, and I'm going to minimize this if that's okay, so that we can see my full window. The first page up here in the right-hand side in the content editor, we tried to give a little bit of direction in what the project's intent was. I do want to point out that we did this in the education version. Education version has some options in this content editor that might not be available to the retail. Most of the information, most of the pertinent or essential information, we made sure was available in both versions. So please don't feel like you're not getting the vital information if you've got the retail. It will work in retail, and you'll have everything you need. There just is some additional tips and tricks for teachers, things like that, that's in the education version. Again, you can navigate forward and back by using the buttons here on the next page, and it will bring you to here. If you have questions about where to find the blocks, if you don't already have them, if you download the project file but forgot to get the blocks, there's the link here that will take you to where you can get the blocks. If you need help with building ideas on how to build a robot, you've got options here that will take you to web page. Basically, I'm just going to tell you, this project was built around a 2-motor robot with the motors mounted in opposition. Maybe this would be a good opportunity to kind of take a picture of this base, or show this basic robot. So let me pull this back up and go to.
Click your webcam.
I hope everybody can see the webcam now. This is a basic TETRIX robot. I tried to keep it as simple as possible when I was doing this for testing. It's just got 2 motors that are mounted in opposition, DC motors. I've got a DC motor control box. I've got a servo control box. I've got a servo mounted here on my very front that I can use to test servo functions. And I've got some LEGO sensors. I've got a gyro sensor up here on the top. I've got a LEGO touch sensor, and I've got a color sense, EV3 color sensor on the front. So it's not anything fancy. It was just basically intended to provide a TETRIX base and use the LEGO controllers for testing purposes. So any 2-wheel design will work with this project file. So if you've got 2 motors, again, they're mounted in opposition. That's how I wrote this file, but you could actually play with the file and make it suit whatever build that you have. But and that's part of the fun of this, is that if you've got a different idea for a build, you can actually create that and then play with the project file and see how it impacts your robot. It's a really good idea one of the nuances that I want to make sure everybody's aware of with these programming blocks, it's important that the startup process. So when you actually start your robot up and connect it to the computer the first time, if you don't have this the TETRIX part powered on before that you actually start the EV3 brick up, it won't see this port that I've got these boxes on correctly. The EV3 has a what we call an auto ID feature that it will know intuitively what sensor is plugged in the sensor ports. But when I have a sensor that is a third-party sensor, if I'm not giving the right information back to the EV3, then it doesn't know what that sensor is. So part of that being able to send the right information back is dependent on whether or not these boxes have power. So it's a good idea to make sure, again, that you power on the TETRIX portion before you power up your EV3 brick. I did that just a little bit in delay, so we'll look here in a minute and make sure that it sees the high technique control boxes correctly. You can do that on your robot by going to the actual view port in the tab on the EV3. I can actually choose that, and I have my boxes plugged into port number 1. I don't know that you'll be able to see this in the webcam, but if it's recognizing the TETRIX sensor correctly, port number 1 will show actually a question mark. It doesn't know what sensor it is, but to the right of it, it says that it's an I2C bus that's looking at, and it should have a 0 information. That is telling me that I actually am recognizing the port correctly. Inside my project file, under the teacher notes, there is a screenshot of that so that you actually see that. But that's going to be important when you actually start programming. So that's what my robot looks like. Yours can look a little bit different. Again, basically 2 motors, and you can use that to actually do the project.
So this might be a good time to ask this question about the difference in max and prime. So the parts on this robot are max, but what's keeping prime from being used in the robot?
Actually, nothing, because if you look closer, this actually is a combination. I actually have my max base where I've got my DC motors mounted because I want the strength down there. But if you see up here, my construction for my Lego pieces is actually made from prime beams. Prime and max will bolt right up to each other, so it becomes very convenient and easy that when you want size and strength, you can certainly use the max larger components because that's what you're going to get with them is the strength. But when you need to get a little smaller detail, then it's easy to go ahead and move to prime and then actually build in a little bit smaller resolution, and it actually provides the clue. But you could actually do this same entire build out of prime. The only thing is, again, these blocks are made specifically to talk to the high technique controllers, which use the 12-volt battery supply and the DC motors. So that's a big consideration for when you're building your robots is being able to connect those and use those the real estate that those boxes take up, and then also the 12-volt battery. That's a fairly big battery compared to what we normally use with prime, so that takes up some real estate, creates some weight, and makes the use of the DC motors practical. So other than that, you could use prime just as easy as you could max. That answer that question?
Yep, thank you.
Good. Okay, so if you got a robot and you're ready to go with the, should we leave the webcam up? Or?
Fine.
Okay, it's up to you.
Yep.
Okay. If you got your robot and you're ready to go into your project, we can go to the next page. When you do this, the software is designed so that it will automatically open up a basic program. We tried to write the project so that even if you were the most novice programmer or had never used the EV3 program before, you won't have to worry about being able to successfully write a program. The program will come up. This will actually download to the EV3 brick, and as long as you have a basic configuration correct, it will go ahead and execute. I'm going to go ahead and plug my robot in so we can talk a little bit about how these blocks show up. So let me go ahead and plug in my USB port. In my software in the lower right hand corner now, you see that I've made my connection to my EV3. This is my information block. It tells me that you do want to have the latest version of firmware installed on your EV3 brick. That's kind of what and this is the most up-to-date version of the Mindstorm software, so that's going to be kind of a good thing for you to have to make sure everything is working like it should. When I look at my port view, you'll see that again I have the 3 LEGO sensors, but number 1 is not showing up again because it doesn't know what kind of a block or a device is attached in the LEGO world. But believe me, if it wasn't correct, it would show a problem up here under the port where you choose the port option on the programming blocks. So in addition to that, we've got, again, a basic configuration based on this program. We want to make sure that our motors, controllers in sensor port 1, it's the first controller in the chain. And the whole idea behind this first programming block is we just want to make it move. I want to make sure everyone is also aware that a couple of good ideas to get in the habit of when you're using the EV3 software is to enable the help, the context help, which is kind of a floating window that will give you kind of on-demand information about different programming elements or different elements in the programming environment. And you can see that when I move my mouse over one of the high-tech TETRIX blocks, it actually shows that in the help menu, and then you can click on that and get directly to the LEGO help that gives you all of the help information about the TETRIX blocks. So I want to encourage people as much as possible to go ahead, feel free to look at all of the information within the help menu. Again, we've tried to make that as helpful and beneficial as possible. And if you got questions about why blocks are doing some of the things they're doing, or why it might not be behaving exactly as you expect it to behave, I would certainly recommend that the starting point is to go directly to your help menu and look and make sure that there's not information that covers the question that you have there. So good idea to leave that help menu open. I also tried to take advantage of the software and actually make some notes within each one of the programs that kind of help explain what we're doing. Again, in this first block, I want to make sure, because I'm using time, I'm just telling my motors, I might not have encoders on them, so I'm just telling my motors to turn on for a certain period of time. I actually turn off my timeout. That's the very first thing that I do, and that's what the developer that created these blocks for us actually recommended. Then I go to a simple move motors. I'm going to turn my motors on. I'm just going to tell them to move unlimited. Again, I've chosen my first controller box. I'm going to talk to both motors at the same time. I'm going to give them a simple power level of 20. One of the differences between LEGO motors and TETRIX motors is you can, it's much easier to take advantage of the lower speeds. These are very torquey, powerful motors with a 12-volt power supply. So unless you're just needing the high as fast as you can, very seldom, for most cases, do you power close to 100%. You can, and that's obviously an option for you, but most of the time you don't need to. So I've got my motor set for 20. I wanted everyone to also notice that with that power level, we actually have a slider bar, and you have a choice of going actually positive or 100 positive to a minus 100. And what that really is telling the motor is which direction to go. So if I set my motor to a power level of 100, that's not only telling it to go full speed, but it's also telling it a direction to turn. And on the opposite of that, if I set that to a minus 100, that would be full power in the opposite direction. So that power level also relates to direction of rotation. So good thing to keep in mind. Again, we can use sliders, or we can actually just type a value in if you wanted to. So I'm talking to two motors. I'm giving them the same power level, which in theory, if I've got two motors mounted in opposition and I'm giving the same power level, my robot should drive straight. That's the idea. Now, again, I'm actually, because of motors in opposition, I am reversing one of the motors. Physically, if I have them back to back, for them to work together, one has to turn in one direction, the other one has to turn in the opposite direction for me to get motion that is working together. And I hope people could see my hand directions there. I hope it made sense. So that's important to realize. If I didn't invert one of my motors, basically what my robot would set and do is spin, because one motor is going to go in one direction and the other one in the opposite. So it's important to kind of make sure that you understand that distinction there. Then when I'm giving them the same value, now if I made that a negative value, so I'm telling one positive, one negative, then that would be the same as actually telling both to go forward. So I'm getting a high sign that I'm taking too much time. So I'm going to go ahead and try and speed through this. So again, the idea behind this is that it's going to walk you through step by step, working the very basics. Each time you click this tab, there is actually about 9 different programs that you can actually go through, and it's going to take you through. And as you step through, you'll open new tabs across the top. Again, try and explore the different features. We did try and give warnings here in the context menu that, again, or the content editor, about encoders. They're necessary to take advantage of that. Again, as I'm stepping through, I see I get a new window open up with a different program. Let's just make sure everybody, this other one, this encoder values on screen. I can minimize this so that we can actually see what the program would be. I can bring that down. Basically, I'm just reading my encoder values, and I'm displaying that information on the screen of the EV3 brick. So that's one of the bonuses that you can do. To download that, again, if I'm connected to my robot, all I need to do is click on the download arrow. And because it's taking a little more time, because I've got so many things attached to my computer, it's going through a hub. So it's going to take a minute to get that, but I should get a beep here that it downloaded the program. There we go. So it sent the program to the brick, and I'm actually ready now to go and execute that if I needed to. So again, there is, if I look at this, about, I think, total 9 different programs. We go through motor movement. We talk about servo movement. Actually, one of the programs is pretty cool with this, because I'm reading the value from the gyro sensor, and as I change the position of my robot, my servo is actually moving my little dial indicator here, so that it actually performs like a compass. It can tell you how far you've moved off course. So simple things like that are kind of fun to do. But that's, again, one of the programs that you can download and try. How are we doing on time?
Just a few more minutes.
Does anybody have any questions about any of this? Is it making sense to everybody?
We will provide a recording of the webinar. It will be on the pitsco.com/webinars page, as well as available on the TETRIX website. And those of you who were registered for and who participated in the webinar will receive a link to the webinar recording as well.
I will say that we have heard very few cases of people that have tried to download the blocks and they haven't imported correctly. A couple of them we know for sure had antivirus activated or security software on the computers that interfered with the download. So if you try and do this, the download the programming blocks, not the project, but the programming blocks, you have issues, please don't be afraid to email us and let us know. Again, we've had very few problems, but it's not totally unheard of because of not only antivirus but security software or administrative privileges. If you're in a school, sometimes importing some of these kind of things gets to be a little bit of a sticky issue. So don't be afraid to let us know if you have any questions on that. The project file is, again, an EV3 file extension. I have seen cases where a browser, like for instance Internet Explorer, might not recognize that file extension and might change it for you. For instance, I might add a zip extension on that project file. If it does that, you can simply either change it back to EV3 or simply just delete the zip if it's added a .zip on the end of it, and your project will be ready to go within the Mindstorm software.
All right, if there's no other questions, we'll go back to the PowerPoint. There's just a couple of things to let you in on. We have social media available specifically for TETRIX, so you can connect with us via social media, and those social media links are listed there. And lastly, if you do not currently receive a TETRIX robotics catalog, you head up to the next one. You can go and request a catalog, or there's also the PDF available for download at tetrixrobotics.com/catalog request. So those are available to you at any time if you just head to the website and check those out. If there are no other questions, we'll wrap up, and thank you everyone for joining us today in our webinar.
I hope everyone found that beneficial information. Again, if you have additional questions, please don't be afraid to email us at or contact us at pitsco.com. I think support at pitsco.com will get a question into us, and we can actually help address that. But we hope everyone takes advantage of the EV3 blocks. Again, it was a big project for us. We had a lot of users that have been asking for a long time for native programming blocks for the EV3 controller with their TETRIX hardware. So we feel like this was a big step for us to be able to provide that, and hopefully everyone's going to take advantage of it and create some really cool TETRIX builds with the EV3 controllers and be able to kind of integrate them right alongside their Mindstorms robots.